The situation was to construct an innovation which incorporated aspects of both technological design and science. The timeline was a month, and our innovation must be unique. The initial major hurdle was formulating an idea which is feasible, unique, and encapsulates and demonstrates the knowledge we have learned over the semester in both science and tech. Our final product was required to be completely functional and not to be working only in theory. The concept was good, however, it was beyond my technological capabilities to construct this. This design is neat and symmetrical, which would provide stability. However, it may be difficult to balance the suspended parts. This is a very neat and efficient model, which is simple but has a degree of complexity to it. The concept and design are efficient and effective, however, it may be beyond my technological ability to make this function, and this function is considerably more difficult to make than the rest. This fan was stable, and the motor fit snugly. However, the fan spun too fast and the thread was constantly flying off. In addition, the motor was too small and additional circuitry, such as resistors, would be necessary to deal with this problem. These mistakes are what led me to my final motor. This is a very powerful fan, and the size made it ideal since it's easy to carve holes to place this in. However, this motor is 12 volts, and I was unable to acquire a 12-volt battery, so unfortunately I was unable to utilize this. This pin was initially a good idea, as it clung onto the fabric really tightly. However, after utilizing it a few times, I encountered a few problems. It prevented me from pulling the motor as it became stuck in the cylinders or the bins, which caused a massive problem. Therefore, I opted to go with the paper clip. I decided to utilize this type of thread above others since it is durable, and it will not become as heavy as other threads when soaked in the water and ascorbic acid solution. The point of the code was to turn on a DC motor when an object is detected by the ultrasonic sensor. For electronics, I utilized an Arduino, breadboard, wires, a 9-volt battery, a 9-volt DC motor, a 9-volt DC motor attached to a fan blade, and an ultrasonic sensor. First, I made sketches from several angles. Then, I traced the dimensions on the wood. Afterward, I cut the wood utilizing a saw. Then, I cut holes in the top of the wood. Then I set up an Arduino motor, the fan, and an ultrasonic sensor. I inserted the motor and ultrasonic sensor in the holes. Then I created a 2x6x30cm box to store the electrical components. Firstly, I cut two 7cm diameter circles and glued them to either side of the pulley. This is to ensure that the thread wouldn't come off the motor. Then, I got a piece of wood in a hole and I placed the motor inside of it. After several trials, I noticed that the motor wasn't pulling in the string correctly, so I added a small red cylinder in order to tighten the string so it would be pulled in much more efficiently and smoothly. I glued them adjacent on the plank. Then I put the band around the second one, as it didn't glue on properly. In the end, I believe that my construction of my innovation was successful, but there are still some aspects that are left to be desired. What went well was, my pulley functioned smoothly and it was simple to operate. Secondly, the swimmer was fully submerged in the solutions as intended, and it worked. Given the option to construct this again, I would have added another pulley on the opposite side for a smoother execution. I could have found a larger, more effective fan blade as opposed to the original one, since it was quite weak and didn't produce that much wind. Lastly, I would make more neater cuts into the wood, as some of them are jaggedy and additionally, I would make the bins less steep and less vertical, because at times it was difficult for the cloth to pull through the solutions due to the bins and due to their angles. Ultimately, I feel like my innovation was a success.